I request Mr. Vijay Mehta, please. Your actually video is going on, so please turn off, Mr. Vijay Mehta. Okay, sir, you can continue, sir.
Okay, thank you. Good morning, everyone. And as we go ahead in this session, I'll try to go with the presentation which we were discussing earlier. And this time we'll be having enough time, so we have 1 hour to spend. So in that 1 hour, we'll try that how good we can create interest in our actual implementation of Internet of Things. So you people had taken an initiative to join this course on Internet of Things and machine learning. It means you have a driving force for that, and you are for a purpose in this course. So unless until you dive into the water, you cannot enjoy the strides of the water. What I believe is, sitting on the bank, you cannot enjoy all the things. So to start with, I'll start from the presentation which we were discussing earlier. So this time, this is the Internet of Things hands-on experimenting, that's hands-on experience. So before we go ahead, let me tell you, so there are various ready-made technologies or ready-made microcontrollers, microprocessor boards, and all these sensors are available with us. And even the piece of code required for running those boards is already available on internet. So initially, when you start with the IoT, you need not worry that how I will be able to code it, how about electronics. Being a mechanical engineer, I don't have much idea of the electronics. So they are basically plug and play kind of modules. Just you plug all the required hardware, and you may even download the software as well and customize the softwares as per your requirements. So these are various microcontrollers on which most of the projects of IoT initially can be started with. This is the Arduino Uno board, Raspberry Pi board, or this is the BeagleBone, and this is the Intel Galileo. So other boards are also there. So I'll show you other boards as well. So this is how this board, Arduino board, say we have, and we want to assemble this Arduino board with various input and output kind of environment. So this is the output monitor 16x2 LCD, and there are some components. Maybe it could be a buzzer and all the temperature sensing. Other sensors you can also embed in this breadboard. So basically, the two very general purpose boards, microcontrollers, which are being used nowadays in IoT or mechatronics or embedded systems. Yes, please.
Sir, your screen is not visible. You're not sharing your screen.
Yes, please.
Sir, your screen is not visible, sir. You're not sharing the screen.
Okay. Just wait. Sorry. I hope now it is visible.
No.
Screen is visible.
Yes.
In the screen. So let's go ahead and see. So there are two. I was talking about Arduino and Raspberry Pi. These are the two boards which are being used most often in all the applications or the projects being made in the field of mechatronics, embedded systems, and IoT, you can say even. So this is the Arduino board. So it has various input and output modules. Here you can supply the external power to this board. This is the microcontroller, and it is the USB port. And these pins, black pins, when we say, these are the general purpose input output pin, GPIO. This side also and this side also, both sides, these are the GPIO pins. In these pins, there are basically different types of pins which are used for giving input and taking output from this microcontroller based on some logic. So the thing is, there are major category of these two pins which you should know at least. Is the one are the digital pins and another are the analog pin. When I say analog pin, it means it varies the voltage from 0 to 5 volt, and it is able to take any voltage between 0 to 5 that is being supplied by some sensor. Say you have used any sensor and that sensor is working, taking some readings of temperature, it may be reading of humidity, it may be reading of moisture, whatsoever sensor you are using, that will give us a signal, which the signal will vary from 0 to 5 volt, and that signal we can supply here because these are the input boards, input pins, and these are taking the input in the form of analog signal. So here we can supply the voltage 0 to 5. In the digital pin, there are two modes in general. Either they are known as high or they are known as low. When we say high, it means this pin will be at 5 volt, and when we say low, it pin will be at 0 volt. So there are two options only in case of these pins. But you can see here a small symbol. These are the symbols for PWM, pulse width modulation. So pulse width modulation enabled pins, how many pins are there? There are total 6 pins in general. So these, for the Arduino Uno, these pins are known as PWM pins, enabled pins. Here you can supply or take in or out in analog kind of input between 0 to 255. So we'll see in the project also how this PWM pin is being utilized for creating the variable input or output. So in detail, you can see here, these are the pins, various pins. You can see here 1, 2, 3, 4, 5. These are the 6 pins, and these are the 2 pins from where we supply the code to this programmer, TX, RX. TX means this is transmitting, RX means for receiving. So these 2 pins are used for uploading the code or the logic in this Arduino board. So Arduino board has this CPU, main controller is at Mega 328P. So this is the main controller. These pins are the controller pins which are somehow joined with these pins, pin headers, so that we can easily use it. And various parts on this regulate the supply and generating of the basically clock signal, and moreover converting the communication modules from serial to parallel or parallel to serial. And so this way, in general, you can know this is the Arduino board. So this Arduino board has input and outputs. They are to be utilized, and we will supply the code from these 2 pins, TX, RX, and ultimately once you connect this port, USB port, to your computer, that computer will start communicating with this Arduino board, but that communication internally takes place through these 2 pins. Whenever you are supplying code to this Arduino board, always make sure that these 2 pins are open. Nothing has been connected to these 2 pins, TX and RX. They should be open at the time of supplying code. So let us see the difference between the Arduino and Raspberry Pi board. So this is a microcontroller and this is a microprocessor. When we say microprocessor, this is higher capability and it can used to process the data, maybe image, audio, anything can be processed. For image processing, even we can use audio processing, image processing, we can use this Raspberry Pi board. Or for machine learning purposes, we can also use Raspberry Pi board. But Arduino is a board which is to be used when you have something crisp to be taken in or taken out. Maybe you are using some sensors, those are giving some input, and that input is to be transported to some website or through Bluetooth or anywhere you want to take them out. So the Arduino is to be used there. So it has a RAM of 2 KB, it has a RAM of 1 GB, and it has a CPU architecture of 8-bit, and it is working on 64-bit operating. It does not contain any operating system because at Mega 328P itself gives you functionality of programming those pins. Those are the digital pins and analog pin. You can program those pins. We will see in the program how you can program those pins. And here is one operating system available, and that operating system could be Raspberry Pi or other Windows-based Windows 10 IoT also. There are so many operating systems which are available, which have to be installed into the Raspberry Pi board before you can use the Raspberry Pi board. So here is the speed. This is 16 megahertz. This is 1.4 gigahertz, and power consumption is 175 milliwatt. And in this case, this is the 700. Now the price, as far as price is concerned, this is approximately say $350 you will get from online websites. So this is at a cost of 3,200 rupees. So these are the two boards which are most oftenly used, and we have compared these boards, and we'll see two applications, one on Arduino and another on Raspberry Pi in this session. So let's skip for now, and switch the camera so that we can see various things on the table. So now you are able to see the camera. You can pin on my camera in which various objects are visible. So this is the Raspberry Pi board. Let me show you. First project we will do is in detail we'll discuss how the Raspberry Pi board can be used for taking the various readings to the websites. So Raspberry Pi board inbuilt comes with a shield that is the known as hat in case of Raspberry Pi board. So this is the Raspberry Pi board. You can see here there are the four USB ports. This is the Ethernet connection, and here these are the GPIO pin, general purpose output input pins, as they were in the Arduino also. In this case also we have the pins, and here is the HDMI port. In this HDMI port, you'll have to take the output and set it to the monitor. So we have to connect monitor with this HDMI port, and while uploading the code, we should use this memory card. This is the memory card. Class 10 memory card is suitable for this Raspberry Pi. I have used 32 GB memory card. Once you have this memory card available with you, just fitting it into the jack and using it into the your laptop, you can upload the software, that is the operating system, in this card only through the website. Let us see how we can upload the operating system into this memory card, that is the memory chip. First process is you'll need a memory card that would be maybe approximately 32 GB is sufficient for this. So 32 GB memory card you need, and you just insert that memory card into your laptop and just search the Raspberry Pi.org, as you can see. So as you go here, you will see the software section. In the software, once you go into the software, for installing the Raspberry Pi operating system into your memory card, you have two options available. One is that directly you use this pink box. In this, it says choose the operating system and choose the SD card. Here you can choose the operating system and you can choose the SD card as well. But I prefer that you should have downloaded the operating system first and then you install it. So manually install an operating system image. So that is a good option. In that case, in case you want to install again, the whole time would not be wasted again. So see all the download options. In the download options, you see that there is a Raspberry Pi OS. This is the Raspberry Pi OS with desktop and recommended software. So you should go with this. Just you download it. Once you press download, it will start downloading, and here it is downloading. I have already downloaded it, so let me cancel it out. Let me show you in the folder. This would be the file which has been downloaded. So 2.8 GB approximate. As you unzip this, you will get approximately 8 GB of this software, that is the image. And then this image can be burnt on this card, basically, which you have installed in your laptop. So once you burn this image on this memory card, you are good to go with this memory card. That now the fully installed memory card is readily available with you. Now let me get back to the camera only. Earlier I was in PPT mode. So you have this memory card available with you. Now this is a freshly bought this Raspberry Pi board. I have done nothing with it. Just I had this memory card and I had installed the operating system as I told you. After installing the operating system, simply plug in this memory card here. In the bottom side, there is a pocket in which you can install this memory card, or you can plug in this memory card. Once you plug in this memory card, now this will be functioning as a computer. This is totally a computer, and this computer can be utilized as we attach various modules to the computer. We need to attach one keyboard, we need to attach one mouse, we need to attach one output module, that is monitor. So monitor has to be attached with this HDMI port. Here you can see this is the HDMI port. In this HDMI port, you will have to attach the monitor. Once this monitor is attached and keyboard is attached and mouse is attached in the USBs, there are 4 USBs, two are say utilized in attaching the keyboard and mouse, 2 are still free. Now once they are attached, you have to provide power to this board. For providing power to this board, adjacent to HDMI port, there is a micro USB port. In the micro USB port, if you plug in the supply, 5 volt supply it needs, it may be at 2 amperes or 4 amperes. So here let me fix here the supply. Once we give supply, you can see the lights has started turning on and off. So this represents that the board is connected. Now once the board has been connected, this board will be viewed as an operating system as we start the Windows. In the same way, on the TV, say you are connecting this HDMI port to the monitor sometime might not have this this HDMI port input. So what you can do is you can use your television TV set for this output. So you can attach your TV here. Once you attach the TV, you will see on the screen, this kind of screen would be visible on the TV screen. Now this is the TV screen on which this screen is visible. And this arrow is moving due to the mouse. As I am moving mouse, and the keyboard is would also start functioning. So the whole operating system would be ready to use in case of Raspberry Pi once the operating system has been installed in the memory card and the memory card is plugged into Raspberry Pi board, and Raspberry Pi board is attached with the monitor as well as keyboard and mouse. So initially it will ask, because it has asked me what language do you want and geographical location, where do you want to set this place settings, time settings, that I have given it, nothing else. Once I had given these things, this screen will appear. this screen will appear. Now you can see in the Raspberry Pi board, there is an option of programming. So these are various programming modules. Node-RED is a module, Scratch is a module, and these are various options in which you can program. But we need Thony Python IDE for programming in Python language. If you don't know Python, please don't worry, because it is far simpler than the C language or the Fortran language in which we used to work initially. So it is very close to MATLAB language. So you just go through the basics in various websites. Python in 3 hours, learn Python in 2 hours. Just go through that and install the Python environment and do a small practice on basically control loops and the basically looping and the controls structure. Once you have done that, you are good to go with Python language. So once we open it up, Python ID basically, in which we will write the program in Python. So here you see that I have already opened a program in it, and this program was written in Python language. So here you can write any program. Now you will see that there are lots of lines written in this program. So need not worry that how these codes will work. Initially, you should have a little bit knowledge of Python, and after that, once you know Python programming skills of the basic level, then you want to say integrate this Raspberry Pi board with this SenseHead. SenseHead is a separate module which comes for Raspberry Pi. It has different sensors embedded on it. 6 sensors are there available on this SenseHead, and along with this sensors, there is a output module also. These are basically LEDs, and these LEDs are 8 by 8 LED board is there. On this LED board, you can display various things, display various characters, and there are sensors embedded on this board. This is known as hat. Whenever you apply any extra module on this Raspberry Pi board, those boards are known as hats. And in this case, this is SenseHead because it is sensing the environment, maybe temperature, humidity, pressure, all the things, and acceleration. All the 6 sensors will be working once you install it. Now you see I am installing this SenseHead into this Raspberry Pi board. For attaching, simply you'll have to make sure that these holes into this pin header should exactly sit on this top of this basically Raspberry Pi board. Now you can say the Raspberry Pi board is attached and it is showing me glowing lights, so it has been attached rightly. Once it is attached, now I can use all the functionalities available in this SenseHead in my Raspberry Pi board. So what we can do is, now you see once I have attached SenseHead to it, now I can perform various functions through this SenseHead. Like we have folders in the Windows, in the same way this is a window in the Raspberry Pi board in which these are the folder option, in which if I press, I go into the documents and then go, these are the folders which I have created here. Say this is a SenseHead, various programs which I'll make to control this SenseHead or to talk with the SenseHead. I have created those files into this folder SenseHead. Once I open this SenseHead, simply one message I had shown you, that in case you want to show the welcome message. So how to write that program? Just you open it up and open it up with Thony Python IDE, say. This is the inbuilt ID in the ID. When we say this is a compiler where we can code the various modules. So here First line is from sensehead import sensehead. These kind of lines are mostly written in Python. What for these lines are written? Basically, when we say import, import means sensehead has a separate library, and that library we need to import in this program so that sensehead can be controlled. So from sense underscore head, we are importing this library. Once we have imported this library in the variable sensehead, and we are importing sensehead. So sensehead is a function now. This whole library is a function which we are allocating to the sense variable. Once we have used the sense variable, now sense dot show. On this sensehead, I want to show a message. Here I have written welcome to IoT. Say we use this welcome to IoT, and text color is basically you can use these combination of text colors RGB. This is the amount of R, this is amount of G, and this is amount of B, RGB. So these combination you can give. So here you will give the text color TC, which has been already initialized or already mentioned, and here you will give the background color. And this is the scroll speed, that is to be kept how fast the characters will move on this. So let me run it. Just wait for a while. So now let us run this. As I run in the camera, you can see it will start showing the message. Connection got interrupted. Let me connect again. Say we run this. Now you can see the digits are going on this 8x8 LED. So whatsoever message I have written, that message is being displayed on the Raspberry Pi. You can see in the camera. So this is the welcome to IoT. Whatsoever message I have displayed. Through varying this speed, you will be able to vary the speed of the text on which this text is moving on the screen. Once you have done this, let's do a few more programs. This was the simple message. Now say you want to sense the temperature, humidity, and pressure through this sense head. So what you will do is, let me open it with the ID, Python ID. So now you can see this is the program for taking the input of temperature, pressure, and humidity, which would be sensed by this sense head integrated on the this Raspberry Pi board. Initially, we'll have to first of all import this sense head library because we are using sense head. Then we are importing time also. Time basically we can import in Python that may give us various formats of time now. What is the time now? And we may compute various times also. So, and from time we are importing now ASC time that gives us present time. Right now, what is the time? So these are simply imported. And now once we have imported this sense head, initially we write sense clear. Earlier you have seen that sense is already used in the previous program. Now we are using sense dot clear so that the sense head is clear of all the text which is being displayed previously. And these are the background and foreground colors. And now we are here in the while loop. So while loop means we want to sense the temperature, pressure, and humidity infinitely continuously, because In while we have written true. True means this while will be continued infinitely unless until we stop the program. Here you can see this is the temperature, this is humidity, and this is pressure. Simply writing sense dot get underscore temperature. This is a standard function of the sense head. You write this line, it would give us the temperature in some variable. In this case, I have taken T, in which this variable is being stored. And similarly, I'm accessing the humidity and pressure also, and those are being also stored in the different variables. And the temperature I'll get would be a very real number, maybe up to 10 places, 5 places. But what I want is, say it is 20.2356. I am not interested in 2356. Maybe to single digit I am rounding off. So temperature is being rounded off, humidity is being rounded off, and pressure is being rounded off. Once we have rounded off these values, temperature, pressure, and humidity, now let us create a message string that would be displayed. In the message string, this part is the constant. T is equal to, H is equal to, and P is equal to. These three are the constant ones, and percentage D denominates, this is a variable, this is again a variable, this is again a variable. So we are desiring three variables in this whole string. How many variables are there? We are interested in three variables. What are those variables? After percentage, we'll have to mention those three variables. The first variable will go from this place to this T here. This percentage D will take this T, and next percentage D will take H, humidity, and next percentage D will take P as a pressure. So once we have taken all these inputs, now what we are interested in, we want to show these values on the sense head. So before we start the next program, let me first close the previous one. So let me stop that because welcome message was going on. So I have stopped that. Now let us see. This message is being written, and this is scroll. This should scroll on the screen, and speed I have taken is 0.1. So let me show you, first run it and see whether this screen will start showing the message. Okay, T is equal to 33 degrees. So the thing is, you are able to see the temperature, pressure, and humidity values on the sense head 8x8 LCD screen. So far, I hope it is clear that we are able to show this message. The message which was made here, and we have given this message variable here, that is a string basically, and scrolling speed along with foreground and background colors. So here we are, once we write this print message means it will print on the console. First printing was on the 8x8 LCD screen on the sense head. The next print is printing on the screen. You can see here we are able to print this value. Whatsoever is shown on the screen, this is printed on the console also. And similarly, now we want to print this message in a file, and that file is a .txt file. So we are opening a file named homeweather.txt, and for it is in the append mode. It will keep appending the data, and log is a variable we have taken. So we are opening a file now in the append mode so as it can take data. But when we are giving data, it should also contain the time value, that when this temperature was stored. So the thing is, we have taken this time now, a variable in which we are taking the str in the string form time now. So this function gives us exact time now, and here we say update message. Message earlier was not having time, so this is the updated message in which we have time also, which is joined with the message earlier which was having temperature, pressure, and humidity. So now I'm saying that okay, print this updated message. It will print on the screen. Now printing on the screen, you can see Friday, February 26. This is time, year, and these are the three values of temperature, pressure, and humidity. So this formatted message is printed on the screen as well. We are now writing log.write update message, means the file which we had opened with the variable log. In that log, I am writing something, and then I am closing that log.close. Now let us see, close it off. Let us stop it and try to open this log file which I was talking about. So this is the home weather.txt which has been created automatically. Here you see these are the values being shown here. In the last, these are the values. Now February, whatsoever message was displayed there, it has been stored in the .txt file as well. So this is how the temperature, pressure and humidity can be recorded in your files, or that can be recorded in MySQL as well. There you can download the MySQL server for backend database management. So you can log these values in the MySQL server as well. So let me close it down. Once we are good to go with the temperature, pressure and humidity, whatsoever sensing, maybe it is temperature, it could be anything. So what the type of sensor you are including, that sensor will give us some reading, and it is very easy to take that reading into your files, or basically on the SenseHead or console you can see various readings. Once we have taken reading, now the next step is, let's go ahead and try to email this matter. Whatsoever is recorded, that has to be emailed, say. So let me show you. So let me stop this, everything whatsoever running. Now you see, if you want to email something, then you will need this SMTP lib library, which is SMTP library. SMTP is protocol which is used for mailing purpose. So let us import this SMTP lib and SSL secure socket layer. So SSL is also imported. Once you have imported it, now we are also using the multi-part function. Multi-part function gives us the functionality in which you can format the mail, you can put the data separate for the subject, separate for the body, and all the parts can be kept separately. So we are using this multi-part library also. So email.mime.multipart and import mime multipart. So this line, once you write, these two lines will be used for mailing purpose. You need not worry. On website you will see various websites give these kinds of portability for the mail. So here from email.mime.text, now you import mime text also. Mime text converts into plain text, and that plain text is being mailed further. So now after this mailing environment is completed by these three lines, then you have to import this SenseHead library file, that is SenseHead, and as we earlier imported time and ESC time, that has already been explained. Now what you'll have to do, you'll have to create mailing environment, that is the sender mail and the receiver mail. I have written the two mail IDs here. Then you'll have to create a variable, you may name anything. So message is equal to mime multipart. So this message will contain each and everything which has to be sent, the data to be sent, used to be for sending the mail. In the message from means from which mail ID you want to send it. The sender email, basically sender email variable has already been created, and then to means to which you want to send, that is the receiver email. This variable has already been created, and then is the subject. You can write anything in the subject. I have written welcome mail from weather sensing station. So this is the subject of the email which is to be sent. And here, as we have done earlier also, the temperature, pressure, humidity is being rounded off and created a message. And once that message has been created, here starts the message.attach. Now in the earlier message there were three things. One was from, another was to, the third one was subject. Now we are attaching body to it. Basically what the body should contain. Body should contain the message MSG in the plain form, plain text format. So MSG we have created here. You can see temperature, pressure, humidity. So this should be contained as plain text in the body of the mail. Once we have completed the message, now here comes the mail sending part of this module. This is SMTP server, SMTP Gmail. This is the standard because Gmail uses SMTP server, smtp.gmail.com. This is the server address, and port number it uses is 587. For Gmail it is fixed 587, and this is the password which you are supposed to give for your mail ID from which you are sending the mail. And then is the server. Here you connect the server. You are contacting the server. Server is equal to smtplib.smtp. This is a standard line, smtp_server port. So here you are giving this address, basically SMTP server as well as the port. So you are defining which server to contact. Once you have contacted this server, here you want to start the communication. Securely connect means start TLS. So TLS is a mode in which it tries to contact securely to that server. Once it is contacted, now you are trying to log in that server. Login will be done through sender mail ID, sender email, and the password. Then it will be able to log in into your mail account. Once it has mailed, now finally we have converted the whole message into the text as string. Once we have converted into text, then there is this server.sendMail. Now this is the line which is sending the email. Now we are instructing, once we have logged into the server, we have logged into the mail ID. Now we are instructing, okay, send mail, server.sendMail. In this we have to give things: sender email, receiver email, and the text. Whatsoever text we have generated, and text contains the whole message, which was having 4 components as I explained earlier. And then the server quit means close the server. You should never keep this open. You should close this server as well. So this was the whole piece of code for mailing. Now let me show you. Let's run this code. So it is showing that it has sent this temperature T is equal to 34, H is equal to 44, and let me see whether we are able to get this message or not. Okay, welcome mail from weather sensing station. So the mail I have already got in my mailbox, and it shows me whatsoever I have written in the body as well. That is the temperature, humidity, and pressure. The message which was structured has been available on my mail ID. So I am able to email through this Raspberry Pi station. The next one is, let's now upload this data to the website. When I say you have to upload the data on the website, there are free websites which provide the functionality to make your feed available on the website. And the best one for the beginners are ThinkSpeak and this Adafruit. These two I have tried and both are working very fine. So you can use here Adafruit. Let's show how this Adafruit can be incorporated into your this program, so that you are able to send the whole message to the Adafruit. Here you can see these were the lines which we have used already, and system SYS we have also imported. Now you see here what line we have written is from Adafruit_IO import client. So we are trying to import this Adafruit library which will connect our app to this Adafruit website. So AIO, we have generated a variable so which takes the detail of this client. This client is, say, my username on the Adafruit ID, and this is the IPE available. This is the key available, API key available on the website. Let me show you how this Adafruit works. This is the Adafruit station. In Adafruit, you go into the feeds, you can create new feed here, and these were the feed already created. And here are the dashboards. These are the two dashboards being created here. So you can create here dashboards and the feeds. And this is the key for the already created accounts. So this is the key which I had given here, my API key. Copy it from this place, and this is the username. Copy the username and this API key and paste these two into the Adafruit website. So here initially when you want to start, you will have to create a dashboard. Say these are the view all, and you want to create new dashboard, just press it, new dashboard. It will ask the name. You may give some name, say test, and create. Simply the test is created in the dashboard. In the dashboard now you can create various feeds from this. So it will take time. So let me show you. You can see some video how to create feeds and dashboard in the Adafruit. That would be very simple. So I have created a feed here in the name of room temperature. So let me show you. It is taking the data from my Raspberry Pi board and displaying on the website. Now the data has been uploaded on the cloud. In this cloud, I can do various data analytics, and various triggers can be implemented. So let me show you the Raspberry Pi board again. So let's get back to this. So we have established the client with the username and the API key. Once we have established, then you see this is the temperature feed, which is a variable which I have decided is equal to a.io. AIO, basically I am providing feeds to this AIO variable, and the feed name is room temperature, which I have kept on the website. You can see here I have kept this feed name room temperature. Please bear in mind there is R capital and T capital, but when you write in the Raspberry Pi program, you'll have to keep it small in the small letters only. So this is the room temperature. Once you have given it, now the rest thing is sense head clear. This was the whole we have done earlier also, and here we are sensing. Once we have sensed, after sensing, now we are providing the feeds to the online website through this line. Basically this line is the line which is sending our data to this cloud only. AIO.send data. In the bracket you have to mention tempfeed.key, basically which key, what is the key where the data has to be sent, and then basically T is the variable which we want to send. T is the temperature in this case. Now once we have sent, this will be displayed on the website. This message I have written simply to see whether it should also show on the console, so which we have already seen. So say I run this program. So it has given the 35.2 temperature to the website. Let me see on the website dashboards. Okay, on this dashboard Pi station, so 35.2. You can see here on the dashboard I am able to see the temperature which has been sensed by my Raspberry Pi board and has been uploaded on the website. Anywhere in the world I can see this temperature, how it is being behaving, the particular environment. So as the Raspberry Pi board updates this 35.2, the temperature is not changing. So as it will change, it will give the temperature change on the website as well. So you can see here feeds. Let's go into the feeds. Feed is the room temperature feed which we are assessing. So in the room temperature feed, you can see this is the graph how the temperature has been fed in the previous days also, and this is the, you can see 35.2, 35.2, 35.2, 35.1. Very fast this whole data is being uploaded on the cloud for the further analytics purpose. Once we have sensed the environment and uploaded on the cloud, almost you can say one loop of IoT you have completed. After this, what happens is this data has to be utilized for further triggers and further processing. And I have also used this website Ifttt, that is the uh, Ifttt website, which is a free website. And what it does is it takes the feed from the other websites and then makes triggers. If something happens on that website in my feed, it will give me alarming situation. So we can basically set various triggers in this. Let me show you in this case. I hope I am able to cover this Adafruit part completely, and this is being uploaded. You can see that it is running continuously. So it is updating continuously. Once it is updating, now I'm using another website, that is the ifttt.com. This is the website where you create triggers. What the triggers are basically, trigger means, say on website on cloud I have updated some data, and if the this thing happens to my data feed is basically temperature. If temperature goes above 30 degree, then I want to do something. If the temperature goes below 20 degree, then I want to do something. So what is to be done in that case? We'll be trying to do some actuation part, and that actuation part can be done through this website, say Ifttt. So in this website, what we can do is go into the settings. Once you log in into it, then you can create here. I have already created one if then situation. That is the if. Basically, let me edit it. In the if part, you can see I have given the feed name here. I was having their bulb, room temperature, welcome feed. It will automatically fetch from Adafruit. Once you log in to ifttt.com, then it will ask for the Adafruit username and the API key. Once you give the API key and username to this website, it will automatically fetch all the feeds being provided on that website. Say I have given the room temperature. Okay, room temperature. So if the room temperature is greater than, say, I say 20 degree, let's update the trigger. Then I say, okay, let's complete the then part. Then I am to send an email. In then I have established a email only. Then send me an email. Email it will ask, and it will ask the email ID address. In that I have sent, okay, temperature is high. You write simply the temperature is high, and the body, in the body of the mail, it should be, hi, please turn on AC. Okay. Now let's update this section. Okay, let's go there again. So go into the my applets, and I have created one applet, this. If data on bulb feed is something I have written, so let me connect it. Once I connect it, based on that trigger, it will start sending me an email based on the data input. Let me see whether I'm able to get some email from this. As the data is changed, because that has a lag of 5 to 10 seconds, based on that, it will create a trigger, and that trigger will let me know So you can see there are 6 feeds already available because it has run 6 times. Let me make it off, disconnect it for the time being. Now you see whatsoever I have written is available on my mail ID. Okay, temperature is high. Hi, please turn on AC. The temperature is high. So this kind of trigger I'm sending to email. These kind of triggers can directly be sent to the controllers as well. And those controllers will take the data and will actuate from the pins, and from that pins from the relays, we can turn on the devices or turn off the devices. So this is how the actual implementation of this IoT can be realized through a simple Raspberry Pi board. Any queries, please? Anybody having any queries, please?
Dear participants, if you have any query or question, you can ask.
Sir, good afternoon, sir.
Good afternoon, Ji.
Sir, if I'm using a solar panel for 5 volt, can I analyze that using this Raspberry Pi as you have discussed now? If I want to check the irradiance or moisture content like that, in my area of interest is to check the fault in my panel. Can I use this concept what you have explained now, sir, using Raspberry?
Even you don't need Raspberry Pi for that, because you are not doing any analytics in that case. You simply want to access the states, whether it is 0, 1 or kind of voltage, what kind of voltage it is giving or not. So in that case, you can simply use the Arduino board, that is 500 bucks only.
Oh, okay.
So Raspberry Pi is needed for the higher end applications.
Okay. For this simple application, I can go for Arduino itself.
Arduino, you go for Arduino. That would be most suited for you in case you want to sense any environment or sense the variables. Basically, you want to be check the behavior of the installed solar panel, how it is functioning, what voltage it's giving or not, whether it is turned off or turned on. So you can go for Arduino. That would be most suitable, because GPIO pins are more capable in case of Arduino in comparison to Raspberry Pi.
Okay, so thank you, sir. Thank you, sir.
Yeah. So any more queries anybody is having? Nitinji, I hope we are done with.
Okay, sir. So participants, if you have any query or question, you can ask right now.
In case anybody is interested in doing and the part which I have explained, you can contact me anytime in case you find any problem.
Great, sir. Definitely, sir.
The participants can contact me as well.
Sure, sir. Sure. So thank you very much, sir, for your session.
Thank you.
Few of the points which we have discussed in this session are we have learned about the IoT. Actually, this session was more on practical aspects. We have seen the different circuits like Arduino and Raspberry Pi. We have seen the what is the architecture of the circuits, different parts and its functions, and we also understood about its operating system. And sir has also explained about the software which is used and how you can download and you can use it. And we have also seen the programming, how the programming is done in the IoT, and also the demonstration, and that Ifttt website you can use for performing this type of programs and to make IoT projects. So this was really very practical and practical based session where a lot of things you have discussed. So this was a very wonderful session and very informative session. And thanks, very thanks to sir for this session. And in future also, sir, please connect with us today.
Thanks for your nice words. I enjoyed thoroughly. But it is not a basically in physical mode. Such sessions are more valuable, I feel, when the participants are readily available and they also do something on their hands-on, basically.
Right. Because of some of the limitation, because the time is going on in such a way, some limitation. That's why we are doing this training online.
But it was wonderful. It is wonderful time to have such trainings because people are comfortably joining these sessions and they are not even used to travel such a long distances.
In future also, sir, we will plan the offline training in our institute. So definitely we will do as you want, sir.
Okay.
Okay. So thank you very much to be a part of this training teachers training program, sir, and have a nice day, sir.
Thank you, Nitin. Thank you. So nice.